Good day, and welcome to the second episode of Conversation with the CTO. I'm Jonah McLeod, and joining me is SimplEx Micro CTO Thang Tran, best known for architecting the first RISC-V vector processor, now shipping in Meta's MTIA accelerator. Last week, we talked about the SimplEx performance model and how it's able to run software before silicon exists. This week, we've reached an important milestone. Dhrystone, matrix multiply, TinyML, and Qwen have all run to completion on the performance model. Thang, is this one of those moments where the architecture starts becoming real?
It is an important milestone. Performance model is 10,000 times faster in RTL. There are benchmarks like spec-in, which could only run on performance model but not on RTL. It is not common, but our performance model is available to customer for evaluation and use in their system as part of the hardware-software co-design.
For people watching this series, it might sound like the hard part is over once the benchmark runs. From the team's discussion, it sounds like that's actually where the next phase begins. What's the difference between getting a benchmark to run and proving the results are correct?
The performance model is like designed in RTL. It can run benchmark, produce result data, but how reliable are the data? The validation process including many steps, test cases to prove that the result data as expected from the specs. The result data must be correlated with the RTL. Our correlation process including both low-level and high-level correlation. The high-level correlation compare the IPC, the point misprediction rate, the instruction and data cache miss rate. The low-level correlation, which is unique to our performance model, is having the same pipeline output for comparison with the pipeline output from the RTL. Pipeline output include the result, the execution, writing back to rest file, and retiring of every instruction with respect to time.
The benchmark that seems to get everyone's attention is Qwen. Why is a workload like Qwen such a good test of a processor architecture?
So we are in the AI age. The Qwen is used for AI capability of the language model and inference performance measuring. It measures the token per second, the memory footprint, and the memory latency. One of the most important invention of our CPU VPU is the memory latency tolerance. Our performance is the same with either 10 cycle latency from L2 cache or 100 cycles latency from DRAM. Our vector processor does not need a high bandwidth memory, HBM, and the data can be fetched directly from DRAM, in which we outside all the solution with using NPU, TPU, or GPU. The Qwen result data from our performance model will show the equivalent of better performance than in comparison to other solution. Our solution is basically a fraction of area and power in comparison. Power is the critical factor that everyone talk about, but have not made any much progress at all.
The team is now talking about correlation between the performance model and RTL. Why is that such an important step before anyone starts talking about performance?
RTL cannot lie. They design must make timing for certain clock frequency. The instruction must be actually executed and produce the correct result based on the instruction set simulator. The low instruction must hit in the cache and fetch the actual data from the cache. The brain instruction must be predicted and executed correctly, or it will have many bubbles in the pipeline. The performance model skip many of the actual implementation. So the performance model must be correlated with the RTL. Furthermore, the performance model does not execute instruction from the wrong path of the Qwen's predictions. The 5% is the allocation for the potential resource conflict due to the wrong path execution. Our goal is to ensure that the performance model is within 5% of the actual RTL design.
One thing that came up this week was the idea of eventually giving the performance model to customers so they can run their own software. What has to happen before we get there?
The performance model is part of the proof of concept. Besides correlation with RTL, we provide package including the compiler, the Whisper ISS, the encrypted performance model, and the four benchmark, Dhrystone matrix multiplication, TinyML, and Qwen. The visual outputs include IPC versus time, capability to zoom into 50 cycle pipeline diagram where the issue, execute, write back, and retire are shown for each instruction. Our package includes options for configuring the memory latency time and the cache sizes. Customer can run their own application to validate the expected performance. Of course, our expert knowledge in microarchitecture and optimization of assembly code can hand-hold in the customer to achieve the desired performance.
Well, the big takeaway this week is that the conversation has changed. A few weeks ago, the challenge was getting the benchmark to run. Today, the benchmarks are running. Now the challenge is understanding the results, validating them against RTL, and turning the performance model into a tool that customers can use. Thanks for joining me. We'll talk about the memory wall, why memory latency matters, and how architects think about solving it. So we'll see you next time on Conversation with the CTO.
Thank you, Jonah. Bye.
Thank you. Bye.